This video is an introduction to how to use Microsoft Excel for purposes of building models. The mechanics of using Excel, I provided some sort of self-learning material, some exercises you can work through. It's really up to you. If you feel like you don't have much experience with Excel and don't know the mechanics well, you can go through that. Most of it is relatively basic Excel techniques, but it also has some more advanced things. I'm going to use a variety of those techniques in this video, but my focus here is on how to build models in Excel, not how to use Excel mechanically, but how Excel is a modeling environment. And the example I want to use is a car leasing business, which is an important component of the business. And I'll actually try to model this after a BMW 320 series car. In the United States, BMW's approximately 46% of the cars are leased. So it's almost half of the cars sold in the US are sold through leasing operations. It's a very important part of the business. And I'd like to build a model to try to see how profitable the leasing business is and why it's profitable or what might make it not profitable. I want to be able to examine the profitability of the business. So that's the model I'd like to build. And when I want to build a model in Excel, I usually start with pencil and paper or something not in the spreadsheet. One of the worst habits to get into is to immediately open up Excel, find some numbers, throw them into Excel, and try to build a model out of it. Because if you just throw numbers at random into Excel, they're not going to be in any kind of order or follow the structure of the problem you're trying to model. So what you want to have a sense of is, what does the structure of the problem look like before you sit down and try to do anything in the spreadsheet. So I've created a visualization for the leasing business here. And you will see it's a fairly complicated process. Actually, reopen that. It's a fairly complicated process. The business is not that simple. So what I'm going to do is build what I call an influence chart, an influence diagram. And the way an influence diagram works is sort of in reverse. Start with your objective. My objective is to figure out the net present value of the profits from a leasing operation. The shapes, there's no standardization to this, but I use a hexagon to indicate my objective. And the objective could be more than one. If you're looking at a project, it's natural to think of at least two objectives, one being the duration or finish time of the project, and the other being the cost of the project. So there are at least two objectives relevant there. Here, I'll have a single objective. How profitable is the leasing business? And the way an influence chart is, you work backwards. You start at the final result, and then you say, what do I need to do to get that final result? And you back up step by step. I find it sometimes easier if you start at the back end and then you immediately put up what are the decisions that I get to control. I have control over three things, and I'll use rectangles for my decision variables. How long is the lease term? What interest rate am I going to charge on the lease? And what is the contract residual value? The basic way a lease works is somebody leases the car for a period of time, agrees to pay a certain interest rate. At the end of that period, they have an option to either buy the car for its contract residual value or return the car and then walk away and they do something else. And you get the car if you're the leasing business. There are some subtleties. You can, of course, sometimes they charge a fee for returning the car. There's conditions that you have to drive it less than a certain amount of mileage in order to return the car, or you pay extra for each mile over that. Those are not essential parts. I mean, they're good revenue flows and you make money off that, but they're not an essential part of understanding how the leasing business works. These are the three primary decision variables. And in fact, the lease term, I think, is relatively unimportant here. So I'm actually just going to look at a 3-year lease term and only model that. So now we go back to the far end, net present value. What do we need to know for that? Well, there are actually two sources of revenue. The first source of revenue is how much do we get back at the end of the lease term? Do I get cash for the contract residual value, or do I get back a car of some value? And to get the total residual value, I need to know what is the residual value for each car, and then how many cars are there. We'll get to the how many cars in a minute. What determines the residual revenue we get for each car? Well, consumers will then determine that by making a choice. And their choice is going to look at two things. What is the contract residual value, and what is the car actually worth at the end of 3 years? Based on looking at those two things, the customer will make a choice. Based on the customer's choice, I will get some amount of residual value, which is either going to be this value up here, the actual residual value, or what was on the contract. I'll get one of those two numbers. And then if I know how many leases I have, I get that's for each car, total number of leases. If I multiply them together, I get the total residual revenue from all of the leased cars that I have leased. I'm using ovals to indicate calculations. So anything has to get calculated in the model, I use an oval for. I use triangles, upside down triangles, for basic inputs, or what I'll call parameters to the model. That's just given information. And if I use a double triangle, it's actually something that is uncertain. So it's basic information, it's given information, but it may be highly uncertain. And in fact, this is one of two critical uncertainties in the problem. You don't know what the car is going to be worth at the end of 3 years. For two reasons. One is the condition of the car may vary, and the second is market conditions change. The options available to consumers are different than they were 3 years ago. So one of the biggest uncertainties about the leasing business is at the end of 3 years' time, you have fixed the contract residual value on the contract somebody signs, but what the car is worth at the end of 3 years is uncertain. The other source of revenue you get is from the leases. You actually make net revenue from leasing. It's actually a negative net revenue, as you'll see, because you have costs, but you're going to collect money during the lease from payments on their lease. You get lease revenue for each car, and you need the total leases purchased. If you multiply those two together, you'll get the total lease net revenue, and you'll notice the total leases purchased is also used to get the total residual revenue, because we have a residual revenue per car. If you multiply that by how many leases, we get the total residual revenue. Now, where do the number of leases get determined? Well, we have another key uncertainty. How big is the market, and how sensitive are consumers to the price of the lease? We don't really know that for sure. That's going to be uncertain as well, but it's going to be given to us from outside the model. We're not going to model how sensitive people are to price, but based on their sensitivity, we're going to try to model how many leases we'll actually be able to sell. Well, a key calculation is going to be what are the monthly payments that people make, and that depends on 4 things. You'll notice the arrows going in, there are 4 arrows. How expensive was the car? And again, I'm not going to model that. That comes from outside the model. If it's a BMW 3 Series car, I looked up average price sort of in Chicago, which is the nearest city to where I live, and the average retail price is about $41,000. So there's, from outside the model, a number for the price. If we know the price, the term of the lease, the interest rate on the lease, and the contract residual value, we can figure out what the monthly payments are for consumers. Those monthly payments, combined with how sensitive people are to the price and the size of the market, will determine how many leases are purchased. So that's how this works in reverse. Basically say, what do I need to do in order to calculate that? And all the arrows are things that will help determine those monthly payments. The only missing piece here right now is the cost of running the leasing business. And that's because to run the leasing business, we need money to finance it. And that either means we go out and borrow money, which is the most prevalent way to do this, or we have enough cash. That means that instead of using that cash and investing it in something, we invested in this business. So let's just, to simplify things, assume we borrow the money. And that interest rate for borrowing it is beyond our control. That's just given from the marketplace. So that's an external parameter. That's why the triangle. But if we know the car price and we know the, I'm missing an arrow actually. We need the contract residual value connected to this. If we know what the price of the car is and the contract residual value combined with the borrowing interest rate, that will tell us what our monthly borrowing cost is. How much do we have to spend every month to borrow the money to buy the car that we are leasing to somebody? And that monthly borrowing cost combined with the monthly payments we get from the customers determines our net lease revenue per car. Combined with the leases purchased gives us the total net lease revenue that we get. So I'm going to make this smaller and just keep it on the side, and actually let me put in that missing arrow. Now it's complete. The importance of the arrows is, if you do this really carefully, it will actually help you a great deal when you now try to build a spreadsheet. So I'm going to open an Excel spreadsheet here. See if I can get both of these showing at the same time. And the diagram helps build the spreadsheet in several ways. First, I want to separate it into sections. I'm going to put parameters. Those are given numbers from outside the model up here. And in fact, I know how many lines I need because when I look at the triangles, those are parameters in the model. 1, 2, 3. And this is actually 2 parameters I'm going to use for that. So I'm going to have 5 parameters. Then I have decisions. Those are my rectangles. I have 3 decisions. Then I have calculations. And then I'll have outcomes after that. But let's start by building this. So what are the parameters? Well, we've got the car price, first of all. And I'm going to use $41,000. The typical price for BMW 3 Series car. I have a borrowing interest rate, and let's assume that's 3%. Interest rates are still pretty low, so that might be a reasonable number to use. Then I've got the market size, and I'll explain these in a minute, but let's just say there's 100,000 potential customers in the area for the leasing business, and a price sensitivity parameter. Just put 150 for now. I'll explain sort of how those work, show you that in a minute. And then I have an actual residual value. And I actually looked up in the Chicago area 3-year-old BMW 3 Series, and the average price for that used car was $24,210. Since it's uncertain, we really want to see what happens, what that value might look like, how it might vary, but we'll get to that later on. Right now, I'm just going to put in the single number, which represents the average that I found. And it might be useful just do a little calculation here and see what that looks like compared to the car price. It's about 59%, so it's about 41% of that car is depreciated in 3 years' time on average. Okay, decisions. Lease term, lease interest rate, and contract residual value. I don't think the lease term is critical here. We could have left it out, but I'll put in 36 months. The typical lease, I think actually they've been getting longer now, so many leases run for 60 months, but we'll put in 3 years. Now, the nice thing about decisions is we don't have to have the right decisions here. Ultimately, if we build this model, it's going to help us decide. We're free to decide these things. It's going to help us decide what we should do for these. So the idea of decisions is put in a placeholder, but we want to then vary it. That's the value of having a model, is we should be able to vary these numbers and see how it affects profits, and ideally use Excel to help us find the optimal set of decisions if we want to maximize something like the profits of the business. So I'm just going to put a placeholder of, let's say, 10% interest. And a contract residual value, let's say that it's going to be 0.5 of the original price. So I'm going to put in just, it's the fraction, but the actual value is going to be that times the initial price. Now I get to the calculations. These are these ovals. And if you do this right, then basically each calculation, take the monthly payments, the arrows are an indication of what has to go in the formula. Any arrow pointing into the monthly payments is a variable that needs to be in that formula. If you don't have an arrow pointing into there, it doesn't need to be in the formula. And that's the real value of the influence chart. When you look at the net present value here, there is no arrow from contract residual value to net present value. So when I do the net present value formula, I don't need to worry about the contract residual value. It matters. It's going to affect that value, but it's affecting it through intermediate calculations. The one thing you don't want to do in a spreadsheet is try to build one massive formula for the net present value. You don't need a spreadsheet for that, then you just need a calculator. And in fact, you can do that on paper. The value of the model is that by breaking it into these pieces, we can just build formulas for each of the pieces. And when we get to the net present value, everything that went into any piece before that is going to affect the net present value. But it's easier to understand the model, it's easier to troubleshoot the model, and the model should still take into account all of these things, but the formula for each step is a lot simpler than it is if you try to do it all at once. Monthly payments is a financial calculation, and Excel has lots of formulas for doing this. Financial formulas, the payment function, PMT, is one to use here. And the interest rate, let's have a number of periods. 36 months. The interest rate, well, that's here, except that that's an annual interest rate. So I'll put that in, but I think I need to divide it by 12 because we want a monthly interest rate since we're doing 36 monthly periods. This is the amount we have to finance, what it's worth today, and the amount we have to finance as a person leasing a car is I only have to finance the difference between the car price and what that contract residual value is. Because at the end of 36 months, that's when I get to decide, do I want to buy the rest of the car or do I want to return it? So I'm only financing the difference. So I'm financing the difference between B2 and B11 times B2. There's the monthly payment under the conditions that I set up there. It has a minus sign, and I want to treat this as a price from a customer's point of view. So let me just make this a positive price. I'll put a minus sign in front. So there's a monthly payment. Now, to understand how this market size works, let's go over here and just set up a little table that says price and demand. And let's look at prices that go from, let's say, 200 going up by 50 each time. I'll drag this down. Let's go to 750. I'd calculate demand by taking the maximum possible size here, which is B4. And I'm using dollar signs so that when I copy this formula, it keeps looking at B4 and doesn't move down. That's the absolute addressing as opposed to relative addressing. And I'm going to subtract B5 for every dollar of monthly payment. So I'd say I'm going to lose 150 of those potential customers for every $1 that I charge for price given by E2. So in fact, that's 70,000. Just format it a little nicer. And I can copy this formula down. As the price goes up, demand goes down. $661 puts us sort of right in here. Very few leases. We're not doing a whole lot of leasing business at that kind of monthly payment. The negative signs worry me here. I mean, we should not be having a negative demand. So in fact, I want to modify this formula a little bit and say this is the maximum of either 0 or that calculation. And you could, for instance, put a little graph of this, sort of line chart. I'll put the price on the other axis. Don't need a legend. So here's a picture of the demand. As price goes up, demand goes down. In an economics textbook, we'd have the axes switched, but basically you get the idea. This is a straight line demand curve and basically says that, you know, at our current price, $660 or so, demand has disappeared to almost 0. So if you don't like the way that looks right now, I mean, so this is the value of having a model. We can go back here and say, okay, you know, let's set this at 0.55. Now we've lowered it to $595. And so we at least have some leases here. It looks like we have almost 10,000 leases that we'd sell at that price. So let's just put that over on the side. So that's an important calculation. What are the monthly payments? Monthly financing cost. So with a leasing company, we've got a finances operation, and that's going to be another PMT function. Instead of pulling up that dialog, you can also do it this way. I know it's the PMT function, so what is the rate? The rate is in B3. So this is what we as a leasing company have to pay to borrow the money. We have that interest rate, but per month, so divided by 12. Number of periods is B9, 36 months. And the value, this is the hard part of the leasing business. We have to actually borrow $41,000 because that's what the car cost. So the leasing company buys the whole car, leases it, collects money for 36 months. At the end of 36 months, they either get the car back or the rest of the money. So they're leasing the entire value over that 36-month period. And as you can see, the monthly financing cost is higher than the monthly payments. We don't make money during that 3 months. If, in other words, if the car didn't either come back or we didn't get any money for it, this would be a losing business, because we have a car that's going to last quite a while and is worth quite a bit after 3 years, $24,000. And there's no way you make money just during the 3 years of lease payments. So there's a monthly financing cost. Okay, let's see how we want to do this. Let's do the for each car, there's a residual gain or loss, which means it's the difference between what the contract residual value is and the actual residual value. So I'm going to take the actual residual value, B6, and subtract what the contract residual is, which is B11 times purchase price, B2. So as I have it right now with the 55% 0.55 contract residual value and a residual value that's higher than that actually, the car is worth $1,660 more than I put on the contract. That's what that number represents. One thing you'll notice here in these formulas, if you do this right, there should basically be no numbers in these formulas. The only number I have so far is the 12 for 12 months. And usually, I mean, 12 months is, a year is 12 months. It's not going to change. So it's okay to have the 12 in there. But most of the time, if you find yourself putting a number in the formulas, you should come and put another parameter or decision variable and put the number up there. Because what I like to do with the models is at the end, the calculation section should never have to be touched. Once you've built the calculation section, it should automatically adjust, and all the changes you want to make occur up here, primarily in the parameter section. If you change, or the decisions, you change anything up here, the calculation should automatically adjust, which means they should all be cell addresses down here. Formulas and cell addresses, functions and cell addresses, no numbers belong in the calculation section. Okay, now we have a customer decision. Does the customer return the car? Well, at $1,660, where the car is more valuable than the contract residual value, that means that it'd make more sense for the customer to keep the car. This is something we could relax later on, but for now, I'm going to basically make the simplifying assumption that just says customers compare these numbers, and basically if B16 is greater than 0, they keep the car, so they do not return the car. Otherwise, they return the car. Under these conditions, the customer would not return the car. One thing you might want to do as you adjust your model is just see whether it's performing right. What if we had set the contract residual value at 0.6? Now, the contract says to buy the car, you'd have to spend $390 more than the car is worth. We have the customer returning the car, so that seemed to work okay. And notice the monthly payment also went down, but for now, I'll go back to 0.55. Let's do it this way. Net present value of residual for car. So there are many ways to enter this formula, but let's try if B17 equals 0, so that means the customer kept the car. What are we going to get? Well, what we're going to get is customer keeps the car, we're going to get the contract residual value, but we're getting it in 3 years' time. So the present value of it is actually got to be discounted to the present. So the amount of money we're going to get is B11 times B2. That's right now 55% of the $41,000 purchase price, but to discount it at the 3% interest here, that's in B3, by 3 years, so it's 1 plus B3 raised to the third power. So that's an annual interest rate, it's 3 years' time, so I can do that, or I can do the monthly interest rate raised to 36-month power, but simpler to do it this way. So that's what we get if they don't return the car. If they do return the car, what we're getting is, so they bought the car. If they do return the car, what we're getting is the actual residual value. So what we're getting is B6 divided by 1 plus B3 to the third power. Since they didn't return the car, I'm getting a car worth $24,210, discounted 3 years at 3% interest. What is that worth today? It's only worth $20,000 plus a bit. Okay. We need to now know the net present value of the monthly net lease revenues. So in other words, every month that the person is leasing the car, we are getting this number, but it's costing us this number. And so we have a negative, a net loss each month of the difference between those. And what we want to know is the present value of that. So let's see if we can find an appropriate formula for that. Present value. Present value, total amount of series of future payments is worth now. So we need the interest rate per period. And that is our 3%, but it's per month, so divided by 12. Number of periods, I'll just type it in, is B9. And the payment is the difference between those two monthly payments, B14 minus B50. And let's get rid of the cents. It's easy to look at that way. And we're actually losing money on this, so the present value formula is hold on a second here. Okay, so the present value formula actually, if you read the documentation, it basically says if you put in a positive number here, it comes out as a negative in the calculation because it represents payments that you're making. So here, since it's a negative amount each month, to see the present value of what we're losing, we need a minus sign in front. Okay, we're almost there. Now what we have is the number of leases. And that's just the formula we used for that little table on the right. It's going to be the market size, the potential market size, which is B4, minus B5 times the price, which is in B14. And so we have, let's separate a little bit, the total lease net revenues, the total residual net revenues, and the total net present value. So we have it per car, we just need to multiply by the number of cars. So the lease revenues per car is B19 times the number of leases, which is B20. And better change this so that it's just a number. And we could round it off if we want, but I'll just, you know, with a fraction, you could interpret it as sort of the average number of leases that we have, and the average could have a fraction in it. Just so we hide the fraction, I'll just format it so we have 10,701 leases. So that's on net revenues from leases, which is negative, but then this one is the present value of the residual, which is B18, times the number of leases, which is B20. I guess probably want to change the formatting of that. And we don't want the decimal, but and might as well change the formatting of that. Currency, no decimals. And then we just have to add the two together. My diagram here, net present value. Well, we've used the interest rate already in the calculation, so I deviated a little bit from my diagram. We just need to know the two sources of revenue. So we're going to add together B22 and B23. So we actually made a little over $1 million from this leasing business under these conditions. So one other thing I'll show you on this video, and then I'll save the rest for another video, and that's that what we really want to know is we want to know whether we can do better. Can we do something to these decision variables to improve the profitability? There is a optimization program built into Excel called Solver. I'm not going to use that because it actually doesn't work on this problem. You need a more sophisticated optimizer than that. We have one that we'll be looking at in the course, but for now, I think a better way to do this is to just build a table to explore the possibilities here. So what I'm going to put in my table is a number of values for the contract residual value. Let's say we start at 0.5, go to 0.51, and then 0.52. Let's go up to 0.62. And then in a column here, I'm going to put different interest rates. We could charge 10%, 11%, and let's look at interest rates up to like 25%. Here's the final result, the net present value. Just point to cell B24. I've got my table set up now. What we want to do is we want to highlight the entire table. Under Data, What If Analysis, there is a data table command. Our row is our different contract residual values. Tell Excel to use those numbers in this place on the spreadsheet. The column is the interest rates on the lease. Tell Excel use that cell for the interest rates. It then fills in the table. First, I'm going to format those cells so that they are currency. And another nice thing to do is to actually use conditional formatting. Colors often don't work well, but they do here because it's natural to think of being in the red as losing money and green as making money. And deeper green means making more money, and you can see well, let's see, it looks to me, don't see anything higher. That looks to me like that's the, let me see, another 18. That looks like the highest, so a little over 18 million. Looks like we'd want to set the contract residual value at 60% and 20% interest. There's our 18,129,000. Monthly payments of $609. We are only selling 8,578 leases, but we're making a lot of money off them. So notice the 0.6 contract residual value is just higher than the actual residual value. So in this particular model, all the customers are going to return the cars. We're going to get back cars that are actually worth $24,210, but we're charging a pretty high interest rate during the time of the lease, 20% interest, which is why we're making that much money. So there is a basic model of the leasing business. The next step, which will be in the next video, is to try to take into account the fact that we have a great deal of uncertainty about this number, the actual residual value, and this number. These two are far from known, and we really need to examine what happens when they're uncertain. Okay, I'll stop here for this video.